Okay, so to solve this problem, your first step is you have to draw the free body diagram. So for the free body diagram, so this is the actual system where the tractor, so this is called as a fork time. So all of you must have seen such type of arrangement in the tractor. Okay. So this fork time, it supports two pipes. So each pipe is having the weight, which is a 300 kg. Okay. So here you can see the schematic diagram. So in the schematic diagram, we have shown the pipe A, pipe B, and this fork time. Okay. So whenever we draw the free body diagram, we will separate the sphere arrangement from the fork time. Okay. And whenever you separate these spheres or pipes from the fork time, then we have to show the reactions at this contacts. So these are the support points. So let us take this point 1, point 2, and this is the point 3. Okay. So at the point 1, so just I will draw the free body diagram. So just draw the diagram for pipe A, pipe B. Okay. Now at the point 1, we have the contact reaction. So that reaction will be like this. So this reaction at this point, it will be perpendicular to this line. Okay. And therefore it will pass through the center point. So in the free body diagram, you can show the reaction like this. It will pass through this center point. Okay. Then this reaction, which is a R1, so its angle with respect to this horizontal, it will be, so here you can observe this is 30 degree, this angle, this is 90, and this angle will be 180 minus 90 minus 30. So this is equal to 60 degree. If this is 60, this is 90. So this angle, this will be 30 degree. So this is 30 degree. Okay. So this is the R1 reaction. Then reaction R2 will be at this point like this. It is also perpendicular. So it will pass through the center point. So here you can show that reaction. This is the reaction R2. Okay. It will pass through the center point. So this is the point A. This reaction R2, it will have the angle with respect to horizontal. So here 30 degree, this is 90. So this angle will be 60. Okay. And at point 1, we have the self weight of that pipe 300 kg. So this will act in the downward direction. So actually this is W 300 kg into 9.81. So this is in Newton. Okay. So just I will write here W. Now consider the second pipe. Okay. So at the point 3, we have reaction which is a R3. Okay. So this reaction is perpendicular. So actually R3 and this R2, they are parallel. And this reaction will pass through this center point. So this is the reaction R3. It will pass through this center point, which is a point B. Then at point B, we have this self weight. So both the pipe having the same weight. So this is the W. Okay. So this is complete free body diagram for the given pipe arrangement. Now next step is we have to use the conditions of equilibrium. So we have summation Fx0, summation Fy0, and summation of moment 0. Okay. So first we will use this condition, summation of moment 0. So from this condition, you can find out the one unknown, which is the R3. So for the summation of moment, we must select the moment point where you can cancel out the remaining two unknown. Okay. So just observe, if I select the point A as a moment point, then the moment due to R1, it will be 0 because R1 is passing through the point A. moment due to R2, it will be 0. Okay, so these are the remaining two unknowns. So these moments are 0. Then moment by W, it will be also 0. So just we have to take the moment by this W and the reaction R3. So one equation and one unknown. So we can find out the reaction R3. And after that, you can use summation Fx0, summation Fy0. And from this, you can find out the reaction R1 and reaction R2. Okay, so let's take the moment about the point A. So summation of moment by all the forces about the point A, this is equal to 0. So this is the condition of equilibrium. Now for this moment, we must have the perpendicular distance. So just observe if I take the moment by W. So we don't have the perpendicular distance. Okay. So from the given dimensions, we can find out that distance. So just I will make one construction. So join point A with the point B. So this distance AB, so it is given in the problem. Radius is given 0.35. So this distance is nothing but addition of radius. So it is 0.7. Okay. Then this weight W is acting in this direction. So this dotted line, it is the line of action. Okay. We need to take the moment by W about the point A. So we must have the perpendicular distance. So from the point A, just draw one perpendicular. So this is the perpendicular. So this distance is nothing but the perpendicular distance. So this distance is not given directly. So just consider that triangle. This is 0.7. This angle. So is it given in the problem? So this angle we can find out. This line, which is a AB, is parallel to this line because radius is same. Okay. So this is the radius and it is same for A and B. So it is parallel. So this is 30 degree. So this angle, it will be 30 degree. So this is 30 degree. So this side, which is the perpendicular side, the perpendicular distance, this is equal to 0.7 cos 30. And here we have the W force. Okay. So your moment will be W into distance is 0.7 cos 30. Okay. Now this moment, it is a clockwise. So just observe this W. It will try to rotate the complete system in the clockwise direction. So it is negative. Then next we have the reaction R3. Okay. So for the reaction R3, we need the perpendicular distance. So I will write here R3 into. Now that perpendicular distance, we can find out from this geometry. So R3 is perpendicular for this line. AB is parallel to this line. So R3 will be perpendicular to the line AB. Okay, directly. So this distance AB is nothing but the perpendicular distance for the reaction R3. So you can observe here. This is point A. This is point B. And here we have the reaction R3. Okay. So this is directly perpendicular. So R3 into distance AB, which is equal to 0.7. And this moment, it will be anti-clockwise. So it is positive. So only two forces, one is W and R3. Moment by remaining forces, R1, R2, and this W, it is 0. Because all these forces, they are concurrent at the point A, and therefore moment is 0. And this is equal to 0. So from this get the reaction R3. Okay. So this reaction R3, this is equal to, put the value of weight W, which is 309.81. So reaction R3, this is equal to 2548.71 Newton. Okay, so this is the first support reaction R3. After that, you can use the summation Fx0 and summation Fy0. So for that, we need to resolve the force, which is R1. Okay, so this is your reference axis. This is reference x-axis, and this is the reference y-axis. So the forces which are inclined, or the reactions which are inclined with this standard reference axis, resolve that reaction. So this weight W and this weight W, they are exactly in the y direction. R1 is inclined, so we will resolve the force. This is the R1. So this is x component, so this is equal to R1 cos 30, and this is R1 sin 30. Similarly, resolve the R2. So this is x component and this is the y component. So this is R2 cos 60 and this is R2 sin 60. And then resolve the R3. So this is x component and this is y component. R3 having the same angle as that of the R2. So this is 60. So this is R3 cos 60 and this is R3 sin 60. Okay. And now write the equation for summation Fx and summation Fy. So for summation Fx0, consider all x components. So I will start from R1. So R1 cos 30 positive, then minus R2 cos 60, that means this component. Then we have R3. So again minus R3 cos 60. Okay, so only three forces. This is equal to 0. Out of this, we know the R3. So put this value R3 in this equation. So you will have the equation like this: R1 cos 30 minus R2 cos 60, and this is equal to, just put the value R3 and get this complete value. Okay, so this is your first equation. R1 cos 30 minus R2 cos 60. This is equal to 1274.34. Now use summation F1. Okay, so for the summation F1, this is the first component in the y direction, which is R1 sin 30 plus second component is this component, which is R2 sin 60. Then this is the third component plus R3 sin 60, and we have the weight in the downward direction. So it is minus W, and this is equal to 0. Okay. Now put the value of weight, this value 300 into 9.81. Put the value of R3. All these three values are known, and again get the equation, which is R1 sin 30 plus R2 sin 60. This is equal to, you will get some constant value. So this is your second equation. So your equation will be R1 sin 30 plus R2 sin 60. This is equal to 3678.75. Okay. Now we want to calculate R1 and R2. So we have two equations, two simultaneous equations. So you can solve these two equations directly in your calculator. So let us see how to solve these equations. So select mode, then select the fifth option, which is the equation. Select the first option. This is a two variable simultaneous equation. Okay, ax plus by is equal to c. Okay, so observe the first equation. We have r1 cos 30. So cos 30 is the coefficient. So first coefficient is cos 30. Then press equal to. Second is minus r2 cos 60. So minus cos 60 is the second coefficient. Press equal to. And on the right hand side of the equal to sign, we have the constant 1274.35. Press equal to. So this is your first equation. Now the second equation is r1 sine 30. So sine 30, this is the constant for the coefficient. Then we have sine 60. This is positive sine 60. And right hand side is 3678.75. Okay. After this, press equal to. So this is your first unknown r1, which is 2948.99 and 2548.71. This is the value of reaction r2. So this is the r2 and r1 is 2948.99. Okay, so here we have calculated all support reactions. Support reaction at point 1, at point 2, and at point 3. So this is one way to solve this problem. So second method is you can separate both the spheres from each other and you can draw two separate free body diagrams. So this is the given diagram and this is the that fourth time. Okay, so initially we have considered the single free body diagram, okay, where the two pipes they are in contact. Second method is you can draw two separate spheres. Now separate the sphere from each other like this. Okay. Now on this sphere, we will show the reactions similar to the last problem. So here we have the first reaction, this is second, and this is the third reaction. So this is the reaction R1. It will pass through the center. Okay. Then here we have reaction R2. It will pass through this center. Then we have the weight W. Then on the sphere pipe B, this is the reaction, which is a R3. It will pass through this center. Then here we have the weight, which is a W. And there is one contact reaction. When we separate out both these spheres from each other, then at this contact point, we need to show one reaction. Okay, so let us take this point as a point 4. So if you consider the free body diagram only for the sphere or pipe B, okay, then the reaction will be like this. This is the reaction R4. Okay, so meaning of this direction is sphere pipe A will offer the reaction on the pipe B. That means it will try to push the pipe B in this direction. Okay, and similarly, if you consider the free body diagram for the pipe A, this reaction will be opposite. So this is the direction. The meaning is when we consider the free body diagram for this pipe, then pipe B will try to push the pipe A in this direction. So this is the reaction offered, and this is the common reaction, which is the R4. Okay. So this is your complete free body diagram for pipe A and pipe B. Now to solve this, we will consider the equilibrium for each pipe. So just observe the unknowns for pipe A. So in the pipe A, we have R1 unknown, this is R2, and this is R4. So we have three unknowns. Okay. So right now for the pipe A, we have the concurrent force system. Okay, all the forces, they are passing through this point A only. And for the concurrent force system, we just have two equations, summation Fx and summation F1. We cannot use moment. Okay. If you consider the pipe B, then we have two unknowns, R3, R4. W is known. This is again a concurrent force system. All these three forces passing through the same point B. So by considering the free body diagram for the pipe B, we can use these conditions and we can find out reaction R3 and reaction R4. Okay. And after that, consider the free body diagram for the pipe A. So just consider this free body diagram. So here we have the reaction, which is a common reaction. So this is a R4. At this point, we have the reaction, which is the R3. And here we have the weight, W. Okay. So you can solve this free body diagram for the sphere B by two methods. One is summation Fx and second is the Lamest Theorem. So I will show how to solve this by using Lamest Theorem. You can try by using summation Fx and summation F1. Okay. So for the Lamest Theorem, we will draw this free body diagram. So just extend this line of actions like this. Extend the line of action of R3 like this. So right now the reaction R3 is acting at this point, which is the contact point. We can show this reaction along this line of action. So we can shift the R4 directly at this point. Okay. Similarly, we can shift the R3 directly at this point. So your final free body diagram for the Lamest theorem will be, this is the sphere. At this point, we have the weight in the downward direction. So this is the weight W. Instead of R4 at this point, you can shift this and you can show like this. So this is the R4. Similarly, you can shift the R3 from this point directly to the center point. So this is the R3. Okay. Now this is the free body diagram for the Lamest theorem. We have three concurrent forces. Just we have to find out the angle. So we have to find out this angle, this angle. Okay. So this angle we can find out from the angle of R4. So angle of R4, you can see here, R4, it will act exactly along this line, which is the line AB. Line AB is parallel to this line. And we know that this is 30 degree So line AB is having the same angle 30 degree with respect to x-axis. So R4 angle is 30 degree with respect to x-axis. Okay. If this is 30 and if I draw one horizontal line, this angle will be same. It is 30. So just I will draw one horizontal line here. So this angle, this is 30. Okay. So this total angle will be 90 plus 30. So this is 120. Now for R3, this angle of R3, this is 60 degree. Let's refer the previous free body diagram. If this is 60, this is 60. So this angle will be same. This is 60. So this is 60. So this total angle will be 90 plus 60. So this is 150. And this remaining angle will be 150, sorry, 360 minus 150 minus 120. This is 90 degree. Okay, so now you can use the Lamest theorem. So for the Lamest theorem, I will write this reaction R3 upon sine of opposite angle. So sine 120. This is equal to weight W upon sine of opposite angle. So it is a sine 90 equal to reaction R4 upon sine of opposite angle. So sine 150. Okay. Weight W is known. This is 300 into 9.81. So first equate these two values and calculate the reaction R3. So reaction R3 you will get as 2548.71. And then consider R1 and this equation and calculate the reaction R1. Sorry, it is not R1. This is R4. So calculate the reaction R4. So this is the common reaction for A and B. Okay. And then you can consider the free body diagram for the sphere A. But for the sphere A, you cannot use the Lamest theorem because you can observe here for the sphere A, we have R1, R2, W, and the reaction R4. So total 4 forces at the single point. So Lamest theorem, it is only useful when there are 3 forces, 3 concurrent forces. So for the sphere A, you can use the normal procedure of Summation Fx, Summation F1 and get the value of reaction R1 and R2. You must get the same answer as that of the previous problem. Okay. Okay, so once we get the value of reaction R4 from the FBD of pipe B, you can consider the pipe A. So for the pipe A, I will draw it again. So this is the reaction R1. Then here we have the common reaction, which is the R4. Then at this point, we have the weight W. And here we have the reaction which is the R2. Okay, so here we cannot use the Lamest theorem. So you can solve this problem by summation Fx and summation F1. So here you should resolve the force. So find out the x and y component. This angle is 30. This angle is 60. For R4, from the center of the point 5A, if you draw one horizontal line, this angle, this is equal to 30. Okay. Now this R4, it is along this line. Okay. Therefore, if you draw one horizontal line like this angle is nothing but 30. This is the alternate angle. Okay. So this is your x component and this is the y component for the R4. Okay. So here this is R4 sine 30. This is R4 cos 30. R2, this is R2 cos 60 and this is R2 sine 60. And here R1 sine 30, sorry, cos 30 and this is R1 sine 30. Okay. And then write the equation summation Fx is equal to 0. So here we will have R1 cos 30 minus R2 cos 60 minus R4 cos 30. This is equal to 0. So you will get the equation R1 and R2. One equation. R4 is known. Put the value of R4. So this is 1471.5. So you will have the equation R1 cos 30 minus R2 cos 60 is equal to some constant value. Then use summation Fy is equal to 0. For summation F1, R1 sine 30 plus R2 sine 60 minus R4, so this force sine 30 and minus weight W. Okay, so this is equal to 0. And from this equation, you can find out the, again you will get one equation R1 R2. So this is R1 sine 30 plus R2 sine 60 and this is equal to some constant value. So this is your second equation. This is first equation. And solve these two equations simultaneously in the equation mode and then you will get the value for R1 and R2. Okay. So you must get the same answer for R1 and R2 as compared to the last method.